Hey everyone, welcome back. I'm back with another interesting video. Today is gonna be a very interesting topic, that is you and we together are going to write a code in data flow modeling. Okay, so in the previous classes we have discussed about how to write a code in gate level modeling, and today we are going to discuss about how we are going to write a code in data flow modeling. Okay, so let's not waste any more time. So before getting into the video, if you are new to my channel, consider subscribing my channel and hit on the notification bell. Also follow me on LinkedIn, where I'll be uploading the slides of the presentation of the particular things that I'm explaining here. Okay, so in today's topic, in the yesterday's session we have discussed about what are operators in data flow modeling. Okay, if you didn't see that video, I'll be linking that in the description box. You can go there and check it out. Okay, so in today's class, we'll be discussing about the continuation of operators, nothing but delays in continuous assignment. Okay, this delays is also one more important topic in continuous assignment. Why? Because delay. So, what is the meaning of this? From the name itself, you could say that delay is nothing but it is your pausing the clock cycle for particular period of time. Okay, that means, for example, you are writing some dollar display. Okay, and if you want to after execution of this particular line, if you want to clock the pause the clock cycle for particular amount of time, then you will be giving that delay, and this delay is indicated with hash keyword. Okay, this is hash symbol. Okay, hash, and for how many clock cycles you want to pause it, you can just write it as like this, 5. From this you can say that it is paused for 5 clock cycles of time, and then the execution takes place. Okay, so this is what delay means. Delay is nothing but pausing the clock cycles for a particular period of time. Clear? So in this data flow modeling, you are having like two types of delays basically. One is regular assignment delay, and then is implicit continuous assignment delay. Okay, and there is also net declaration delay. Here this you don't mostly use in data flow modeling. These are the two important you need to consider, because basically in interviews also they will be asking you like which what is this type of delay and what is this type of delay called. Okay, so you should know what is regular assignment delay and what is implicit continuous assignment delay. So regular assignment delay means, for example, if you see here wire result. Okay, this result is of wire data type, and then you will be assigning something into this result. What you are assigning? You are assigning I1 XOR I2. Okay, so this is I1 XOR I2, and this operation, this expression I am assigning into the result. So before result, if you could see, I have given hash 5. So what does this mean? This mean that this execution like I1 XOR I2 will be done after 5 clock cycles. If you see here, if there is any change in RHS, the RHS expression will be evaluated after 5 time units, and the evaluated expression will be assigned to LHS. That means here if you have given any values like for I1 and I2, this operation will be conducted after 5 clock cycles of the before operation. That means what I am saying is, for example, if you are giving like I1 equal to 0, I2 equal to 1, and then I2 equal I1 equal to 1, and then I2 equal to 0. I1 equal to 0, I2 equal to 0. In this you are throwing some values into this two values. Okay, here what will happen after the execution of this particular values, that means after throwing this I1 equal to 0 and I2 equal to 0 for the first time, then the execution will be halted for 5 clock cycles, and then the second values will be thrown into this particular I1 and I2, and then again after 5, again after execution of this particular line, again it will be waiting for 5 more clock cycles, and then this particular execution will be done. That means what? After for every, since you have given hash 5, the execution will be done for every 5 clock cycles. That means your output, when you see the time of the clock cycles, it will be like 0, 5, 10, 15, 20. So at this particular clock cycles, you will get the output, like you will get the result value. Got my point? So in this way the execution will be done. Okay, the same execution, this will also be same for this, but it is just a way of writing. Okay, you can write this hash 5 here, like assign hash 5 result I1 XOR I2. You can either write this in this manner, or you can directly combine these two lines and you could write it like this, like wire 5 result equal to I1 XOR I2. Without using an assign keyword, you can directly write it like this. Okay, you can, this is called as regular assignment delay. That means regularly, normally you will be seeing any delays in the any example programs, you will be seeing this type of writing only. But you can also write it in this way, like wire hash 5 result I1 XOR I2. So they both will give you the same result. There is nothing uh, different in both of these assignments. Okay, and then coming to net declaration delay. Net declaration delay is nothing but you will be declaring the delay with the net. Okay, in the net only you will be declaring the delay. So here, because of this declaration, it doesn't affect the value of result. That means even though you are declaring the result as hash 5, since it is declared in the net, so it won't be affecting the value of result when the execution is done. That means it will, the result will be continuous during the execution of this particular value. Okay, so this is about the delays in continuous assignment. You should mostly remember regular assignment delay and implicit continuous assignment delay. Okay, I think you got my point here. So see here, this is my particular delay. Okay, assign hash 10 out equal to I1 and I2. So what will happen, any change in values on of I1 or I2 will result in 10 time units before recomputation. That means if there is any changes in I1 or I2, they will be only taking place after 10 time cycles. Okay, that means since you have given hash 10, so before 10 clock cycles there won't be any result. That means, oh, within this clock 10 clock cycles the result will be, that means I1 and I2 values will be only their previous values. Like for example, if you are giving I1 as 0 and I2 as 0 and I1 as 1 and I2 as 1, then what happens, after 10 clock cycles only this I1 and I2 as 1 will be reflected here. Until 10 clock cycles, what will be here, until these 10 clock cycles the I1 value will be 0 only, I2 value will be 0 only. After 10 clock cycles only, I1 and I2 values will be reflected in this particular 1 comma 1. Okay, hope you got my point. This is about delays, right? So now, okay, so this is a small concept about delays. Now let us write a code. Okay, as I already told you, let us start writing a simple code in data flow modeling. Okay, if you write the code, then you'll understand. Okay, the more you write the codes in different, because since we are having four different styles, and then in these four different styles also, since we are having many types of operators in Verilog, by using any operator you can write your code. Okay, that is why one code may differ from another code, but the logic, since the logic is same there, by using that particular logic you can write your code in any ways you want. Okay, so let us write a 2 by 1 mux code today. So this is my 2 by 1 mux. Okay, this is the 2 by 1 mux, and I naught and I1 are inputs and Y is output and SCL is my selection line. Okay, and this is the truth table. So from this truth table, what you will understand, this Y equal to nothing but I naught, okay, selection bar plus I1 selection dot selection. Is it or not? This is the logic for this my particular 2 by 1 mux. Okay, now by using this logic I will be writing my code. So first let us see how to write an RTL code. Okay, when coming to RTL code, okay, let us write module, okay, some name M21, anyone, anything. Okay, next, what is it? SCL, I naught, I1, Y. What are these? See, SCL, I naught, I1, Y. Okay, and in this, what are the inputs? SCL comma I naught comma I1. What is the output? Y. That's it. Okay, and now completed all inputs and outputs. That is all we need to write. And now coming to logic, by using this logic, since we are writing in data flow modeling, what is the most important thing that we need? Assign. Okay, assign is the keyword for a particular thing. Now if you see assign y equal to, what is this? Y is output. Assign y equal to, what is that? I naught. Okay, dot means into means and operator. Okay, and then I naught bracket selection bar, nothing but negation of selection. Okay, right, and then this is completed. Plus, that means or symbol. Okay, what is or? I1 and selection. Okay, right, so that's it. In module, simple, that's it. This is the simple code. So you can make it much more easier. How? You can write it either in this way, like this is by using some operators. Okay, and or operators. Okay, some bitwise operators, you will be writing this. Okay, instead of using like bitwise operators, you can also use a conditional operator here. Okay, how? See, assign y equal to, okay, selection. Okay, here if selection is 1, what should be the output? I1. Sorry, this is question mark. If selection is 1, I1 should be the output, or else I naught will be the output. Simple. Okay, is it or not? This is question mark. Selection I1, I naught. That's it. Clear? So this is how you will be writing the RTL code. Now for TB code, what you will be doing here? You will be just passing the values for selection I0 and I1. Okay, got my point? So this is how you will be writing your data flow modeling code. Okay, very simple thing. For 4 by 1 also, 4 by 1 marks also, you will be writing the same thing. After knowing the truth table, you will be writing the logic, and based on the logic, you will be using all this with the operators. Okay, any operator you can write it anyway. Just like this, you can either write it in this way, or you can either use conditional operator, or based on any other code, you can write any other things you need. You can write it in that way. Got my point? So this is how you will be writing a code in verilog. So now let us do something. Since we have already written 2 by 1 mux code, let us execute the code in EDA playground. Okay, let us execute a 4 by 1 mux code in EDA playground, so that you will also know how to write it in manually, and how to execute it in the EDA playground. Okay, so if you see here, this is my mux code. I hope it is visible for you. So basically, when this comes to the mux code here, see, module, any name, again mux example. Okay, in mux code, what you will be for 4 by 1 mux, what you will be having? 4 inputs, 2 selection lines, 1 output. Is it or not? So here if you see, 2 selection lines, 4 inputs A, B, C, D, and 1 output. So these are my 2 selection lines, S0, S1, and my 4 inputs A, B, C, D, and my 1 output. Okay, out. Now what I am doing here, assign out, just like how we have written the code for 2 by 1 mux code by using that logic. Okay, here also you will be using the same logic. What is the logic here? I'll be explaining it to you much more simply. So if you see here, negation of S0, S1. Okay, selection lines, what is the truth table? 0 0 0 1 1 0 1 1. 0 0 means A, 0 1 means B, 1 0 means C, 1 1 means D. Is it or not? So see, 0 0, negation, negation, A, 1 0, B, 0 1, C, 1 1, D. Got my point? So just like this, you will be writing a code, or you can either write it in this way, or you can also execute in this way. If you see here, this is by using conditional operator. Okay, here how this conditional, this is nested conditional operator. Okay, as I already told in the previous sessions, we can also use the nested conditional operator. Nested conditional operator means conditional operator within conditional operator. That means you are writing condition within one condition, you are writing another condition. That is called nested condition operator. So let us see this condition. If you see the condition here, s naught, okay, s1. So if s naught is true, this condition will be executed. If s naught is false, then this condition will be executed. Now is s naught is true, that means if s naught is 1, what is the condition? Then here s1 is 1. If s naught and s1 both are 1, that means if 1 and 1, what will be the output? It is D. If 1 and 0, C. Okay, again if you come here, this is for true condition. What is this? This is for false condition. Now if you see this, if it is 0 and this is 1, that is 0 1, B. Okay, 0 0, A. See, as simple as that. Okay, you just need a practice for this. Okay, there is nothing much you can do while listening to code. While listening to any code, it will be fine, but when you put into practice, then you know how far you can reach in writing that particular code. So try to practice how many ways you can write a code. Okay, this is how you will be writing your RTL code. Now coming to test bench. Okay, how are we going to pass the values here? See, module TB. Okay, since you are given s0 and s1 as input, so they are reg. Okay, ABCD are reg and wire out. And now what you are doing, you are instantiating nothing but connecting your TB to your design code. Okay, and then initial begin. Within initial and begin, what you have done, you are writing a dollar monitor. Okay, in order to monitor all the values, see all the values, s0, s1, a, b, c, d, out. Okay, mostly for all these values, you will only be writing the dollar monitor. Okay, you just will only be writing dollar monitor in order, because dollar monitor, what will be doing, it will be monitoring all the values. Okay, any change in value, it will be displayed, but dollar display can't do that. That is why when you want to monitor the values, when you want to check the values continuously, you will be writing dollar monitor instead of dollar display, because dollar display is used to only display the values, it doesn't monitor. Okay, that means even though there is any change in value, if there is no display in that particular at that particular change, then it won't be showing you the value. But it is not the case for dollar monitor. Dollar monitor will be continuously monitoring the values and it will be displayed on the output. So that is why mostly in order to monitor the values, you will be using dollar monitor system task. Okay, here if you see, this is one way of passing the code. Okay, don't get confused here. You can either pass the code, this is the regular way, like this is how you regularly pass the values. See, s0 s1 a b c d, s0 s1 a b c d. Okay, for 5, this is my delay. So this is a 0 time, and this is a fifth time, and this is again hash 5. Now let us run this particular code. See, if you see my code 0 5 10. Okay, that means at 0th time it is executed, and then next hash 5. So that is why at 5th time it is executed, then after 5 it is a 10th. Okay, 10th clock cycle it is being executed. Now if you see the output, what is the output here? So before going into the output, okay, let us see the inputs that we have given. See, s0 and s1. Okay, mostly when you see the truth table of this also, your output will be depending upon the selection, like s0 and s1, is it or not? So if you see here s0 and s1, what is this? 1 0. So if it is 1 0, what will be the output that is being executed? That is c. So what will be the value of c? That will be displayed. So what is the value of c here? 0. That is why the output is 0. Okay, and then the second thing, if you see 0 1, if it is 0 1, what will be the value that is being executed? B. So that is why, what is the value of B here? 1. So that is why output is 1. If you see the third thing, 1 and 0 again, 1 and again 0 means it is C. Now if you change the output to 1 and 1, and if you change the value of D to 0, now before, if you see, the output is 1, is it or not? Now if you run it, see, the output is, the value is 0, is it or not? So based on the values, you will be either, now if you see here, you can pass the values either in this regular way. Okay, but by passing these values in the regular way, basically what happens means, it may be like tough, like you have to write so many values in order to pass. If you want to pass some 10 set of values, you have to write 10 lines, is it or not? So in order to reduce it, we can also write it in this way. Okay, this is another way. If you see here, okay, what have I done here? If you see, this is the concatenation operator. If you remember the operators, this is my concatenation operator. Okay, for concatenation operator, if you see, I am giving it in a reverse, like DCBA. You can either give it in this way, or else you can give it in normal way. So DCBA is, what is the value I am giving for? Take H5. That means I am giving the value as 5 for ABCD. Okay, so now what happens? The 5 will be value for ABCD, and then S0 and S1 is given as dollar random. So dollar random is a keyword in Verilog, which will be used to produce random values. Okay, randoms means it based on the design, just like when you are listening music. Okay, when you are listening to music, and when you give the shuffle button, what happens? Okay, random song will be played for you in your playlist. It won't be in a correct order, something random, but within your list something random will be played. In the same way, dollar random also, what it will do, within the range that you have selected, like if you see here, it is percentage B, so that is why it can be either 0 or 1. So within that S0 S1 range, like 0 and 1, either it sometimes will give you 1, it sometimes will throw 0. Okay, now let us run this thing. See, at 0 5 and 15, okay, it is 0 1. Okay, first thing is 0 0, it has given. So at 0 0, what is the value of A? It is 1, so 1 is displayed. At 0 1, what is the output? 0 1 means B, so B value is 0. 1 1, at 1 1, what is the output? It is C is 0. Okay, sorry, at 1 1 D, so the D value is 0. So in this way also you can write the values. Did you get my point? Either you can pass the values here in this normal way, or you can do it here, or there is also another way. Okay, without writing all this also, there is, in this way, this I'm just saying like different ways in order to pass your values. You can either write it in this way, like you will giving values like S0 S1, and by using the concatenation operator, you will be throwing some random value into your particular thing. For this also, if you see, S0 S1, okay, 1 0. Okay, 5 means 1 0 0 1. Okay, sorry, 0 1 0 1, 5 means. Okay, so when it is 1 0, what will be the output? Output will be the C, so C output is 0. Got it? Clear? So this is how you will be writing your codes in data flow modeling, right? So this is all for today. We will be explaining like 2 more codes in the next session, and then we'll be jumping into the behavioral level modeling. Okay, so that is all for today. If you like my explanation, just give me a small like, so that it will encourage me to upload much more videos on this verilog and system verilog also. If you like my explanation and if you like this channel, consider subscribing the channel and also share with your friends who are also interested in VLSI front end courses.